In this video, we are going to solve problem 4.112 that is taken from chapter number 4, Pure Bending, and book name is Mechanics of Material by Beer Johnston, 6th edition. So statement is an offset edge must be introduced into a metal tube of 0.75 inch outer diameter and 0.08 inch wall thickness, knowing that the maximum stress after the offset is introduced must not exceed 4 times the stress in tube when it is straight. Determine the largest offset that can be used. So you can see this is the tube that is exerted by a tensile load, clear, and the outer diameter of this tube is given as 0.75. Since it is tube, so outer diameter is 0.75, while this thickness is T is equal to 0.08 inch. And when it is straight, so that is exerted by a tensile load, and then it is given an offset, and this offset is producing the offset stress, and that should not exceed the 4 times the stress in the tube when it is straight. So you have to determine the largest offset that can be used. So let's start with the solution. So what will be the first step? First of all, we will find the stress in this straight tube. So when it is cut at this section, and we will draw the free body diagram, so you can see it is like here you will have a center axial load P. So we will find first the for centric loading, because this load is passing through center of this tube. So for centric loading, we know that stress will be equal to, that is centric load, so stress is equal to P divided by A. Now what will be the stress when we cut this tube that is given eccentric is offset distance h? So when you cut it and draw the free body diagram, so definitely you will be having a center load P, and here you will be having a moment M as well. Why? Because this force is not centric, that is not passing through centroid. Only the load passing through centroid is this one. Both the loads are passing through centroid, but here you can see one load is passing over here and second load is passing over here, and in between these two we have this distance which is h. I will show you in a while, and this produce a couple or moment like this. So this moment will be equal to product of this force into a distance between them. Okay, so I can write it. We will find this for eccentric loading. We will have this eccentric stress will be equal to, now you can see you have two load. One is axial load P, which is producing normal axial stress, and other one is moment, which is producing bending stress. Clear? Both are the axial stress. So it will be equal to P divided by A plus moment into C divided by M divided by I, where P by A is axial force due to normal loading, and MC divided by I is the bending stress. Okay, what will be the value of M? So let me show you over here. You can see if I zoom it, so you will see that this is the distance offset, and if I exceed this line, so you can see this distance is h. Similarly, when you cut it, so you will have this force. So this force is at a distance, it is acting at the center, so you can see this is also center, so it will be also center, and it will be same distance h. So P into h will produce couple or moment in this direction, which will be equal to M, and this M is equal to P multiplied by h. Okay, so hence we will write it over here that this moment is equal to P times h. Now you have all the values. So what we will do is that we have been given that your eccentric load should not exceed 4 times the centric loading. It can be less, but we will take it 4 times the centric loading. Now you have sigma E and sigma centric, so put the value. So sigma E is P by A plus M into C divided by I is equal to 4 times P divided by A. Okay, From here, what we will get is m into c divided by I will be equal to 4p over a minus p over a, and that will give you 3p over a. Okay. Now, as we know that this moment is equal to p times h, so p multiplied by h multiplied by c divided by I is equal to 3p over a. P will cancel on because they are both on both sides, so we will get h into c divided by I is equal to 3 over a. And we are interested to find out h, so h is equal to 3 times I divided by a. So what is I? A into c, where c is the outer radius. Since we have been given diameter, outer diameter, so outer diameter is how much? You can see it is 0.75 inch. So c will be equal to, which is outer radius, that will be equal to d naught divided by 2, and 0.75 divided by 2 will give you 0.375 inch. Now what about inner radius? Since we have been given thickness, so thickness is 0.08 inch, and if I draw a cross section of this tube like this, so you can see, okay, so you can see this is center, so this is outer radius, which is c, this is thickness, clear, t, and this is the inner radius ci, and we can see that c is equal to ci plus t. We need ci, so ci will be equal to c minus t. Okay, so 0.375 is outer radius minus thickness is 0.08, and that will give you c inner, and c inner comes out to be 0.295 inch. Now we have ci and c, so from here you can calculate area. So area of hollow tube is equal to pi r square. If you are using r radius, so it will be pi r square, but it is hollow, so we can write pi c square minus c inner square. Okay, so put the values over here. So area will be equal to pi multiplied by c is 0.375 power 2, clear, minus 0.295 square. That will give you area, and when you calculate it, you will get 0.168389 square inch. Okay, this is the value of area. Now we will find I. As we know that I is the second moment of inertia for tube, it will be equal to pi by 4. If you are using radius, then it is pi by 4 c power 4, and if diameter, that then it will be pi by 64 d4. Since it is tubular, so we will use pi by 4 c power 4 minus c inner power 4, which is inner radius. So pi by 4 multiply by 0.375 power 4 minus 0.295 power 4. And when you calculate it, you will get I will be equal to 9.5835 into 10 raised to power minus 3 inch power 4. Now you have all the values I, A and C. So just plug it in this formula. H is equal to 3 times I divided by A into C. So 3 multiplied by 9.5835 into 10 raised to power minus 3 divided by area is 0.168389, and C is the outer radius, which is 0.375. Okay, so when you solve this, you will get this offset distance H comes out to be 0.455 inch. Okay, so this is the answer of our this question, that an offset distance of 0.455 inch is given to this tube that will not exceed the eccentric stress 4 times the stress when the tube is straight. So that was all about problem about problem 4.112. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon, and also comments on my video by providing your precious feedback. If you have any question, you can ask me in comment section. Thank you for watching.